All right, today we're talking about Chapter 11, Section 1, the fundamental counting principle. Now, every now and then, as a college student, you get thrown a bone from your professor, whether it's a easy assignment, snow day, canceled class, something like that. And while I haven't done that yet, especially since we're online and I can record all my classes and all that good stuff, today is about as close to um, getting getting that day because, in my humble opinion, this is one of the easiest sections that I've ever taught in a college math course. And it really is, I don't know if it gets much easier than this. But anyways, let's begin. And let's go ahead and start with this example, all right? So it's early morning, you're groggy, you have to select something to wear for your 8 a.m. class. Fortunately, your lecture wardrobe is rather limited, so that's good. You have just two pairs of jeans, one blue, one black, and three t-shirts to choose from, one tan, one yellow, one blue. All right, and of course we have, here's our early morning dilemma. So we have our tree diagram here, and we want to know how many possible wardrobe combinations can we make. Okay, well, we have two possible pants and three possible shirts. All right, of course, with the blue pants we have the tan, yellow, blue, and with the black pants we have the tan, yellow, blue. So two pants times three shirts, you get six possible outcomes, and that's as hard as this section gets. I think. Well, there's one little thing at the end, but it's just, you just kind of think about it. Of course, there's always a catch, right? So, the fundamental counting principle: if you can choose one item from a group of m items and a second item from a group of n items, then the total number of two item choices is just simply m times n. We're just doing multiplication. Okay. And we're just going to put these two examples right on the next page. Uh, and here we go, example one. Obviously you can see the solutions, but again, it doesn't get any harder than multiplying. But anyways, so the Greasy Spoon restaurant offers 6 appetizers and 14 main courses. In how many ways can a person order a 2-course meal? Well, 6 times 14 is just simply 84. And that's all I got. Example 2, much the same way. So this is a semester that you will take your required psychology and social science courses. Because you decide to register early, there are 15 sections of psychology from which you can choose. Furthermore, there are 9 sections of social science that are available at times that do not conflict with those for psychology. So, in how many ways can you create 2-course schedule that satisfies the psychology social science requirement? Well, I've got 15 psychology sections to choose from. I've got 9 social science sections to choose from. It's just simply 15 times 9. Okay, and again, this is just simply the fundamental counting principle, just m times n. Now, I will say there are some kind of, I wouldn't say tricky, but some examples towards the end of your homework that you have to kind of think about. But like I said, I'm sure you'll get there, and of course we'll do one of the examples here. All right, so let's crank it up just a little notch here. And what do you think happens when we introduce a third option? Well, what you think would happen. Okay, so let's go ahead and look at the text here. So, whoops, you forgot something in choosing your lecture wardrobe. Shoes. So you have two pairs of sneakers to choose from, one black and one red. For that extra fashion flair, well, oh, that's a comma, sorry. One black and one red for that extra fashion flair. So again, we have this tree diagram, right? Depending on what pair of pants we get, onto the shirt, and then choosing the shoes. Okay. Well, depending on how many options you have, all we're doing is just simply multiplying by that number, that extra number. Now, I will say there will. Hmm, no, I'm not gonna say that. I don't want to get confusing. All right, so we have three items, and depending on how many choices we have of each item, we just multiply it by that number. And of course, we have the two jeans right here, two jeans, times the three colored shirts, times the 2 shoes. Well, 2 times 3 times 2 is 12. So we have 12 possible outcomes. And of course, if we crank it up a notch here, right, if you have 30 pairs of jeans, holy cow, 20 t-shirts and 20 pairs of sneakers, I'm sorry, 12, then again, it's just simply multiplication. 30 times 12, 20 times 12. I'm going to put example 4 up as well. Don't want to have a bunch of empty space. All right, so if the credit card thing was kind of, lots of computation and stuff, which there is, you have to think about it. Hopefully this section is that, a little bit of kind of like having a class off, even though we're really not. So anyways, let's begin over here at example 3. So next semester you're planning to take 3 courses, math, English, and humanities. So based on time blocks and highly recommended professors, there are 8 sections of math, 5 of English, and 4 of humanities. So 8, 5, and 4 that you find suitable. So assuming no scheduling conflicts, how many different 3-course schedules are possible? So again, 8 math, 5 English, 4 humanities. It's just 8 times 5 times 4. That's it. More of the same here. So car manufacturers are now experimenting with lightweight 3-wheel cars designed for one person and considered ideal for city driving. Intrigued? Suppose you could order such a car with a choice of 9 possible colors. So we're looking at 9 colors, with or without air conditioning. All right, so with or without, we're looking at, that's 2 options. Electric or gas powered, that's also 2 options. And with or without an onboard computer, so that's also 2 options. Okay, so 9 colors, 2 options on air conditioning, 2 options on electric or gas, and 2 options on with or without onboard computer. So in how many ways can this car be ordered with regard to these options? Well, it's just simply 9 times 2 times 2 times 2. And of course, 9 times 2 times 2 times 2 is 72. Okay, so this is I promise there is one problem where you actually have to think about it. We'll just snip all that. So, example 5. You're taking a multiple choice test that has 10 questions. Each of the questions has 4 answer choices with 1 correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, how many ways can you answer questions? Well, 10 questions. And of course, never mind this part. I don't actually have my computer in tablet mode. All right, never mind this part, okay, because that could get a little confusing. But I mean, it makes sense when we do look at it, and I'll erase it and it'll make sense. But I mean, if we have 10 questions, okay, and each one of those questions has 4 choices, well, then you just do 4 times 4 times 4 times 4 all the way to 10. And of course, 10 fours multiplied by one another, of course, we know that as simply as 4 raised to the 10th power, or 1,048,576. And so there are many ways to answer a multiple choice question. Just had a thought. All right, I think we'll talk about combinatorics at some other point. I'm pretty sure I saw that. All right, now here's the last problem, and this is the one where you kind of think about it, and you are going to have something similar to this on your homework. Okay, and let's actually, well, yeah, I guess we can just do this. I mean, it's nice and clean, but still a thought process is there. All right, so telephone numbers in the U.S. So if you have, I didn't know this was a rule until this section, but telephone numbers in the U.S. begin with 3-digit area codes, obviously, and 7-digit local telephone number. All right. However, area codes and local telephone numbers cannot begin with a 0 or 1. I didn't know that, but that kind of makes sense. So how many different telephone numbers are possible? Okay. So the way this is broken down is obviously we have our area code, and keep in mind the one that you put in front of the area code for those of you that maybe have a house phone still, that doesn't correspond with the area code. Obviously, it's just I don't remember why we put a 1. but it isn't part of the area code. Anyway, so if the area code cannot start with a 1 or a 0, and the local telephone number cannot start with a 1 or a 0. Okay, so just looking at the area, the first number of the area code and the first number of the local number. Well, obviously, thinking about the choice of numbers, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, all right. Looking at the choice of numbers, we see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 possible choices here. Okay. Well, if we take away the 1 and the 9, we now only have 8 possible choices. Okay. So that's where we'll have 8 times, and then of course our rule doesn't matter with this number or this number or this number, this number, this number, this number, right? All those numbers, it doesn't matter. There are 10 possible choices for all those, but only for the first number of the area code and the first number of the local number do you have 8 choices. And of course, we see this down here, 8 choices for the first number, and then 10, 10. 8 choices for a second number, and then 10, 10, and then all these are 10. And so again, it just becomes a multiplication. You just punch this into the calculator. 8 times 10 times 10 times 8 times 10 times 10 times 10 times 10 times 10, so on and so forth. All right, and getting when you put that into a calculator, you get 6.4 billion numbers. So there are 6.4 possible telephone numbers that can be in the United States. Now, I don't understand. I don't really know how international numbers work, but I'm pretty sure they're a little bit different. I think I've seen some that just have like 9 or 10 digits. I don't know, but it'll be a very long time, if ever, before there are 6.4 billion people in the United States. I think there's only like 7.5 or 8 billion people in the world right now, so I don't think we're in any danger of running out of phone numbers. Anyways, that is the end of this very quick lecture.